Okay, I just want to go ahead and give everybody a few minutes to kind of like log in, a few moments to check in, do a sound check. Yes, we are good. All right, let's get this show on the road. Greetings, tech artists. It's 12:30 and it's Friday, and it means it's time for Tech Art Talk Live. Hi, my name is Chris, and I will be your teacher, instructor, lecturer for the day. And welcome to Tech Art Talk Live. Anyway, this is going to be all about answering the famous question that new tech artists are asking all the time is, do I really have to code? And so this is actually, I'm going to give you a hint, and I'm going to be kind of biased, yes, and I'm going to say this sort of yes, but I'm going to, before I do that, I'm going to go into and give you my whole spiel that I had lectured out for this today, because this is actually going to be the first video of a seven video series altogether. And we're going to have a lot of fun here, and I'm really kind of bullish on where this is going. So without further ado, let's get things rolling and get on to the lecture. But I'm having a little bit of problem with my OBS, and my face is freezing here. So I'm going to have to go and unfreeze my face. All right, so hopefully that has unfreezed my face. Well, thank you very much for your attention and your time and your patience. All right, so once again, we're going to try to answer in today's lecture the infamous question, do tech artists really need to code? And as far as I'm concerned, this is a lot like the absolute answer. The answer is no. You do not have to code. But that also reminds me of a situation that someone once asked their dentist, do I really need to brush? And the dentist said, no. You only have to brush the teeth that you want to keep. And that's a little bit like what tech art is. Because do you really need to code? No. But really, how bad do you want the job? So you got to watch out for glass ceilings. Because if you don't know how to code, you're going to get your head, you're going to bash into some glass ceilings. And the glass ceilings are different for every person. You just don't know when they're going to happen. Okay, they hurt. Yes, they do. It hurts. It hurts your pride. It hurts your feelings, and needless to say, and it might actually cause you some physical pain. Okay, in my humble opinion, now me as a tech artist, I'm very biased. I am not going to hire you if you don't know at least some coding. But then, of course, I've been in the industry for a really long time, and so therefore, I kind of assume that if you're a tech artist, then you can actually handle some kind of coding. Okay, coding is not going to hurt you. Believe it or not, no one has ever gotten hurt, if, at least physically, by learning how to code. It will only benefit. So, my question for you tech artists out there, what are you really afraid of? You know, where's your asbestos underwear? Where are you going to be diving into the fire in order to kind of figure out the next problem and figure out the greatest solution that has ever been thought to man? You're going to need to do a little bit of coding for it, most probably. All right. Now, we've gone over this before when we go with the Tech Art Golden Rules. And one of the golden rules that I think we went over was that if you have to do anything more than twice, then you got to create a script for it. And it just kind of like goes, it kind of makes sense. It says it might be a little bit slow at the beginning. You might have to worry a little bit about time to spend a little time working on the code. But in the long run, you're going to actually end up doing more, more work with less time. So the return on investment of the time that you put in there is going to soon surpass the initial time investment. So overall, if you do something more than twice, definitely create a script for it. Now, if it's doing it just once or exactly twice, well, then it's kind of hard to kind of actually justify it. But anything more than twice, then you know what your job is. Okay. There are a bunch of universal reasons of why it's a good idea to learn how to code. Okay, speed. Tech artists are under the gun all the time. They're constantly putting out fires. They are the consummate fire people of the development industry. They're just running around. They just don't have enough time. So if you create scripts, that gives the tech artist time to do more important things. Now, when the tech artists are running around, they're doing a lot of support type issues, and they're kind of like mending a lot of screw ups, or kind of like patching a bunch of holes. Now, in the absolute scheme of things, those are important because they keep the ship afloat. But in the grand scheme of things, are they really that important? No, they're just kind of keeping everything going status quo. Okay, so creating scripts creates multiple copies of the tech artist. And so just imagine having multiple copies of you running around. That is going to be a really fantastic way of multiplying your output. Now, it's also important when you're troubleshooting. Now, the development industry is fraught with little errors and gotchas and little nuances that are just impossible to kind of incorporate for everything. So when you create a script for things, you create a process that can be tracked and it can be measured and it can be adjusted. And therefore, this process can gone through and you can give an exact reference of what happens and when it happens and the exact time that it happens, and then you can identify where that problem happens with needle like surgeon like precision. Okay, it's also very important for communication. If you haven't noticed this before, communication is the greatest threat for any development company. And the larger the company that you're working with, the bigger the communication issues. And most probably, when a tech artist works on something and they don't create a tool, there's no communication to pass on how did the tech artist actually do that. So therefore, when a tech artist creates code, they're creating a legacy. They're creating something that will live beyond them, because most probably you are not going to retire at the company that you're currently at. Now, some of you may. I could be wrong, but for those of you who are just starting out in the industry and just embarking on your tech art career, this company probably isn't going to be the company that you're retiring with. And these codes, these little snippets of scripts and whatnot, are going to be your legacy. They're going to live longer than you. What they do is they create invisible thought paths for improvement. You might create a tool, you might create a script that does something really awesome. But 5 years down the line, the tools, the technologies, they're going to change. So therefore, you're creating a path for showing, okay, the tools and technologies change. We need to update these tools. We need to update these scripts in order to get them to work with the most recent technologies. We need to improve on them. So therefore, your script shows exactly how and where to improve on things, because they're going to leave holes or gaps or attachment points of where new and future improvements can be put in. Now, in the tech art kingdom, there are 4 various places to work at. And the first is the pipeline. And the pipeline is the tech artist doing whatever it takes in order to get the art from the artist's machine into the real-time experience, into the game, or rendered into the film. Do whatever it takes. Rigging is where you hook up all the skeletons and all the controls, so you get those wonderful character models that your modelers created, and you want to enable your animators to animate them. Rigging basically puts in the skeleton, puts in all the controls, so that the animator now is able to bend, mutilate, and spindle that character and bring life to it. Lighting and rendering has everything to do with look development, uh, creating the way that objects are rendered or appear inside of the experience, or their material components, or how they're or any things that has to do with lighting, rendering, or presenting the way the stuff looks. That's lighting and rendering, and tech artists are kind of like the lords over that. Okay, visual effects. Everyone knows what visual effects is, right? No, okay, visual effects is all those things that are not basically character modeling, prop modeling, environment prop modeling, and not keyframe animation. Visual effects could be considered almost anything that it's not. But anyway, let me get back on the track. These tech art kingdoms, there's four of them: pipeline, rigging, lighting, and rendering, and they're all very, very dependent on scripting. Okay, let's look at the pipeline folks. Now, the pipeline folks do whatever it takes to empower artists to get assets from the thesis. That's exactly what I said before. But one reason, tools. The second reason, tools. Third reason, tools. Okay, tech artists who are working in the pipeline area create tools out the wazoo. Tools, tools, tools. You can't create tools just with good intentions and a lot of elbow grease. You got to create the actual scripts that keep track of everything. There's just no other way of doing it, and you can't code if you can't do pipeline if you can't code. And plus, especially if you're working in the film world or something that has thousands of files, you're going to have to make scripts in order to move things around, change names. Let's say, for example, you've got an iterative title and you're working on, let's just say, Maya. Okay, Maya doesn't like years in their path names. And so if you go or you're working on the 2021 title and then you got to update for the 2022 title, that means you got to go through all of your assets and change their paths from 2021 to 2022. Well, what you could do is create a script that crack open every one of those Maya ASCII files, go ahead and change all the paths names where they're actually within the file, and then save it out again. And you never had to open up one particular Maya file, but then you've gone and you've literally manipulated thousands of files without ever actually having to open one of them. That's a huge time saver. Okay, rigging. Rigging, yeah, it's a you're probably not going to get hired, in the industry unless they really like you if you don't know how to rig. So rigging empowers the rigger, coding empowers the rigger to create endlessly complex rigs. You can really get some complex stuff. Everything's good, doing forward kinematics, maybe doing an IK, FK by hand, but that's when things start to get a little bit crazy and a little bit out of hand. For me, I can't create a rig without my IK, FK switch scripts. I can't do it because it's just too complex for me. Maybe you can do that. Good for you. But there are just too many things to doing. Like when you start working with multiple rigs and multiple layers of rigs, that's when you need coding in order to do this. You're going to create repeatability because I can guarantee you something's going to happen and you're going to have to make a change. You're going to have to make a change to the rig. And so why not create a script for it of where you can just say, okay, no problem. Make a quick change to the script and big, you recreate the rig for your character. Easy squeezy. Okay, flawless prototyping. Okay, and of course AI, but flawless prototyping is you're going to create scripts to do basic certain things. Let's say I'm going to create an arm or I'm going to create a leg prototype. And so therefore, this script can act like a library of that where you link them all together and assemble your character or assemble your rig really quickly. And we kind of gave the hint away a little earlier, but yes, AI. AI is going to be the hammer that strikes hardest for the riggers. I'm sorry, folks. This is where it's going to happen. 5, 10 years from now, everything is going to be automated rigging. And your job as a rigger is going to be having to tell the automation device, no, you didn't create the rig correctly this way, you need to create it that way. Or you need to give it better examples of how it should behave. That is where rigging is probably going to go in 5 to 10 years from now. That's all AI, and you've got to be able to code because everything in AI is nothing GUI driven right now. You got to do everything with code on that. It is really crazy, and I'm just learning a little bit about AI myself, and I'm realizing, oh man, I've got a lot to learn, and I know that this is where rigging is headed towards. Okay, lighting and rendering. Okay, Of course, shader writing, that kind of is obvious. That's a no-brainer. Okay, shader writing, you don't need to code for that, right? All right. Now, if you want custom behavior, like you want your light to behave a certain way, or you want to expose maybe your up vector in your camera, well, you're going to have to be able to do a little bit of coding in order to do that. And being able to code, if you're lighting and render, gives you direct access to the GPU. Now, the GPU is where all the magic happens. This is where everything gets put together. This empowers the lighting artist to jump right in there and start noodling with the controls that they really need to behave. And the next generation of CGI, they've already, you've already seen the announcement for UE5, and the next generation consoles have already been come out here. And in my in my belief, I don't know if this is true, but I believe that everything is going to be going towards ray tracing and volumetrics. Scary, isn't it? And basically, you thought that everything was cool. You said, okay, I've wrapped my head around rasterizing. I can understand it. Cool. Now when we're going to go into ray tracing and volumetrics, everything's going to get much harder. Nothing is easier anymore. You got to be able to understand the scripts in order to make the transition. All right, visual effects. Do I really need to do this? Because they've got like buttons and dials and sliders and all the controls I need to create any visual effects. Yes, that is true, but nobody wants a canned effect. Nobody wants an effect that they've seen before. Everyone wants a brand new visual effect whenever they request a visual effect. Okay, so therefore, one of the things you do is create a custom shader for every visual effect. Custom shaders are fine, but you got to learn some HLSL or GLSL in order to create those custom shaders. Virtual objects are objects that don't exist. Now people are going, what do you mean don't exist? Well, when you get into games and especially into film, you're going to be dealing with objects that are so big and so massive that you can't actually store an instance of them. And they only exist during rendering. And you can't create objects like that without scripting, because what they're doing is they're pulling in pieces constantly all over left and right, pulling together, combining together, throwing them into an FBX file, putting them into a rib file, putting them into a rendering file, and then letting the renderer go onto this. And so this is all just a wild circus, and virtual objects can't exist without scripting. Okay, very complicated behavior. Well, you can imagine that. If you want something that's a little bit more complicated than what is given to you, then you're going to have to write some scripts for it. And some of you folks may have seen this before. Many of the softwares and some of the game engines, support expressions. You immediately get more power once you understand how to do a little bit of expression writing. Well, expressions are scripting. Okay, once again, visual effects, and especially if you're in the film world, you're going to be dealing with thousands of files, and suddenly you realize, oh, we renamed them wrong. Do I have to re-render them all? No, no, you're just going to create a quick script, and bam, you're just going to change it like that. It really is that easy. And so, if you're in visual effects, whether in game or film, you got to learn scripting at some time or another. Okay. Yes, AI is going to be into the visual effects world very, very soon, and for a lot of the same reasons. And you're going to be working with the computer. The computer is going to be developing these visual effects that are so freaking complicated that you can't actually understand them. You could just tell the computer if it's getting close or if it's going further away from the final solution. All right, so take heart. Don't worry about all of this. You don't have to be that awesome of a coder. It's absolutely not necessary. But you can be kind of crappy too. Now, just as an example, I teach tech art, and so I teach Python. And during one of my assignments, one of my tech art students at one time, who will continue to be anonymous, put down 100 copies of the exact same command and then just changed one parameter for every one of those 100 copies of the 100 lines. And of course, I didn't like this at first, but then I realized, so I was hard on this student because they wrote some pretty crappy code. But I thought about it. I said, wait a second. Yes, this is crappy code, but the next time that they run this, it's going to be like that. And so instead of doing those 100 steps, they're just going to run the script again and they're going to be okay. So they might have spent a little bit longer creating this crappy code, but it's still good code and it still works. So yes, you can be a crappy coder and still go to the. You just got to get it working, folks. You just got to make sure that the thing does what it's supposed to do, and then life will be good. Okay, now there is an exception to this. Okay, if you're working as a tools person and you're working inside a development team, they might be a little bit upset when you start putting out the crappy code. They're going to want proper formatting, they're going to want right naming conventions, they're going to want to stick to conventions, they're going to stick to the and I do know that this is true because I've had this come and haunt me because I've talked to people and they were working at a company where I used to work at maybe like 5, 6 years ago, and they go, "Oh, so you're the guy who created that code with those wild variable names?" And I'm going, "Uh-oh." I thought that they would be gone, but no, they stuck around. And so therefore, if you're working with a development team, creating tools for a lot of peaks, they might be a little bit, but for everyone else, go ahead, create crappy code. If it works, you're golden. Okay, the best language choice to use is hands down C++. You're going, what? C++? Okay, it's the Latin of all object-oriented languages. Okay, if you learn C++, then you can speak almost any language that computer language that there is. And almost all the code for any engine or any DCC itself is written in C++. And plus, you're going to develop what I call artist vision. Now, artist vision is a thing that only a tech artist can have because they can code and they're not afraid to go into the code, go into the engine and figure out what's wrong. And so they can see things in an artistic way that programmers can't see. What is obvious for the tech artist isn't obvious for the programmers. And so it empowers tech artists to kind of zero in on problems right away that a programmer are not able to pick up. And once again, we mentioned that we can learn any language overnight. And just look at all of the beasts in whatever facility that you're working at, or look at who the tech artist beasts are. Ask them if they know C++. My best guess is that at least that they know C. I would be surprised, if they just know C, but probably C++. But if you know any tech art beasts, ask them what language that they choose, and they're probably going to say C++. Now, C++ is a bit tricky, and it is a little bit cantankerous. You're going to need at least 3 months of hard work getting your hands dirty with C++ in order to really figure it out. And it all comes down to pointers. Pointers are kind of nasty, kind of like pointers are difficult, and then they cause problems. But once you get through and you understand what pointers are, then suddenly it's all going to fit in and everything's going to click inside your head. But you're going to need at least 3 months to kind of bang it in here. So don't, if you're just sitting around and you've got the C++ lectures going on in the background, not good enough. You got to get your hands dirty. You got to start playing around with it. Okay, so the runner-up choice, if you don't have access to C++, is Python. Now, Python is easier than C++. It's also object-oriented, so it's got a lot of the same ideas and the same concepts that C++ uses. And this will take weeks to learn rather than months. And so that's a little bit faster. Okay, almost every DCC and almost all game engines support some kind of interface for running Python. And so that's really good. And what's cool is that there's almost an unlimited number of libraries for folks who have already written Python code for you that does exactly what you're trying to do. And so you just have to kind of like bring it into your script and then you can use it. Now, this is especially true when you're working with AI. Now, I don't know why. I'm just learning AI myself, so I really am not super knowledgeable, but all the AI I have found is written in Python. And they're all about reading in Python libraries and so forth. So if you're going to be learning AI, you're probably going to have to learn Python one way or the other. Okay, now the runner-up choice, I guess, would also be maybe C#. Now, C# is easier than C++ because you don't have to deal with all the memory. You don't have to deal with the pointers. And it's also object-oriented. And also, you can learn C# in weeks instead of months. And it also does have a very considerable size of libraries. And if you're working in any kind of .NET development, or if you're working in Unity, yeah, C# is definitely the way to go. But regretfully, outside of the .NET development and .Unity, not a lot of folks are using C#. I mean, they do use it a little bit here and there, but if you already have a C++ or a Python understanding, then you can kind of figure out what's going on with this C# anyway. And it will be kind of obvious. Okay, now as a fourth place, you could learn HLSL or GLSL. Now these are niche applications because they're programming languages for the GPU. They're rendering languages. Now they're good, but they're done in a C-like structure, but without the pointers, which is cool. It's not a bad introduction to C-structured languages, but you can't use HLSL and GLSL to do any pipeline work, or you can't use these languages to do any kind of rigging because they're pretty dedicated for just doing things like, painting your spheres red or putting a little nice gradient on your ray marching. So it's a good introduction, but not necessarily great. Now, other considerations that you might want to consider, if you don't like any of these other options that I've given to you, would be Java. Java is really good, especially if you're doing web development and network manipulation. And also, yeah, that's right. If you're going to be doing database manipulations, a lot of these games have huge databases built into them. And a lot of these databases don't have Python interfaces. You got to do everything in Java. So you might want to learn Java or kind of like Java similar languages. But we're straying away from the typical TrekArt stuff. JavaScript is really good, especially if you're going into Adobe products. And if you want like things like Photoshop and so forth, then you got to write JavaScript. So if you're like gung-ho on creating scripts for Photoshop, JavaScript's the total way to go. And others that you'll probably end up learning along the way, whether you like it or not, are kind of like things like Mel. Everyone knows Mel, right? Mel used to be a real wicked language, by the way. But Vex and HScript, and these are the Houdini languages that people will probably need to get familiar with, but as well as Python. So Python is good for both Maya and Houdini. And MaxScript is the language that they use for 3D Studio Max. And Blender actually doesn't have its own kind of custom version of Python, but it is Python. They don't have a custom version. They just have their version of Python, and it's kind of nutty and it's a little weird. I don't really know it very well, but every time I've seen it, my head kind of ended up hurting. But I'm going to have to go ahead and master it because Blender is going to stomp everyone's butt very soon anyway. Okay, so then what we're going to use is Python. Over the next 6 weeks, I'm going to be showing essential programming for tech artists. Now, I'm going to be showing you how to do everything in Python. I'm going to be showing you folks exactly what is necessary as far as Python is needed for the tech artist. Just the basics, just the basic simple Python for tech artists. And we're going to be doing it in Houdini. Okay, why Houdini? Yes, yes, yes. I know. I love Houdini, and Houdini is my favorite package. But in my humble opinion, the object-oriented programming and the API of Houdini is actually pretty good. It's a little bit obtuse, it's a little bit long, but it kind of gives you the essence of what object-oriented programming is all about. And for all those folks out there going, man, I don't want to touch no Houdini. Houdini's just too expensive. Well, you can download the Houdini Apprentice license for free. And working within a real DCC will give you tech artists an opportunity to actually working with tech art problems, because that's what I'm going to be working on for the next week is our tech art problems, teaching tech art skills within tech art tools. Okay? All right. So, but I have to warn you, Python itself is going through a little bit of an identity crisis at the moment. And that's because the entire industry is in the transition, one way or the other, of going from 2.7 to Python 3, I don't know, maybe 3.7 or 3.5. I don't know what people are going to decide on. I guess every package is going to be different. But the visual effects industry has been dragging its feet for years on this. And this transition was supposed to happen maybe 4 years ago, but people have been just saying, no, 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 we don't want to do it. And finally, the folks at the Python said, okay, we're not going to do it anymore. And as of like January 1st, 2020, they said, okay, Python 2.7 is officially unsupported. We're not going to do anything for it anymore. And so that means the folks who are supporting Python 2.7 are all the folks with the DCCs. And that's something that the DCC folks don't want to have. That's right. He's dead, Jim. Yeah, so COVID kind of slowed down the transition. When they finally killed it, then they realized, okay, we're not going to do this anymore. So, but the whole COVID thing kind of like slowed things down to a crawl. So it is inevitable. So I'm going to do my best to teach you folks Houdini, Python 3, 3.5 or 3.7. I can't remember which version it is, but that's what we're going to go on for next weekend. I still haven't created my whole lesson plan yet, but if something changes, I'll go ahead and tell you next week. But it's most probably going to be Python 3. Okay, so week 1, what I'm going to be telling you is basic how to work Python inside Houdini and how to install it and how to download and use it. And then we're going to go over some very simple Python structure. Now, week 2, we're going to go over Python functions, which are super important, especially as a prequel getting into object-oriented programming. And we're going to go into some data types. So the data types give you kind of like a further addition of built-in data into the Python structure. And so you need to have a little bit of understanding of how functions work before going into that data. Now, the third, we're actually going to get into the object-oriented. We're going to give an introduction into Python classes. No, we're not going to do everything, but we are going to show some little bit of cool stuff of how to create Python classes. Now, week 4 is where rubber is really going to hit the road. We're going to go into Python inheritance. Now, this is where things really start getting big and really start getting important. Believe it or not, you folks have already been using inheritance and you just didn't know it. If you've been working in Unity or UE4, you've been working in inheritance every step along the way. And if you didn't know about it, I'm here to tell you about it now. And this will kind of like broaden your horizons and realize, oh, so they're doing there. Okay, so Python inheritance in the week 4. Week on 5, a little bit of nitty-gritty stuff. We got to worry about exceptions. That means like when errors happen, like remember, this is tech art. Errors are always happening. So when errors happen, this tells you how to handle them. And then we're going to deal a little bit with how to handle external files. Mostly we're going to be dealing with JSON because JSON is a real simple, crazy, simple format to bring files in and out of a Python program. And then we're also going to be dealing with XML. You'll still see a lot of XML. XML is a little bit more dicey, but I think it's something that after 5 weeks, I think you all should be able to handle. And then week 6, we're going to be going into interface creation. Python itself does not supply any kind of interface API. And so therefore you have to use an outside library. And so what I like to teach is PyQt or PySide2, which are basically the same thing. And so if you understand how to create interface using these critters, you should be able to understand using any library. If you understand it in PyQt, PySide2, then you'll be able to use anything. And so that's what it is. Really, it's just 6 weeks, and you're going to be up and going and fully functional with Python as a tech artist. See, that's not so painful, is it? All right, great. So thank you very much for joining me today. If you want to get more of this crazy Houdini stuff, join me today for Houdini Secrets Live, and that's 3 o'clock. That's just in a couple hours. And we're going to be going over an introduction to VAT or soft surfaces. Now, VAT or Vertex Animation Toolkit is a super duper important tool that every tech artist and every visual effects artist needs and must have within their palette, because this is a way of getting all the powers of an offline simulation, put them in an itty-bitty living space and putting them into your real-time expression or your real-time application and have them work and look exactly as if they were just came out of your offline application. Really, really powerful stuff, really, really strong stuff. And as a reminder, join me again for Tech Art Talk Live next week, which will be on the 29th. And we will be going over week 1, which is just simple Python basics. See, not so hard. Now, if you liked what you saw today, feel free to subscribe to this YouTube channel by all means. Check me out. Subscribe to me on YouTube. Check me out as Chris Rhoda, that's my name, on Facebook and on LinkedIn. And go and check out Tech Art EDU, which is kind of like the banner in which all of this crazy stuff kind of goes under. Also, check it out on Facebook and LinkedIn. All on there. But if you really want to help me, we got a couple people joining in last time. I really appreciate it. Thank you, all you folks out there who did sign up. Go ahead and go to the TechArt EDU website. That's techartedu.com. And then when you see on the website, there's a couple of little banners there that are asking you to go ahead and click here now. What I'm asking for you to do is to go ahead and sign up for all my information. Once you get signed up, you will get informed of what all is going on, all the latest articles. You'll learn all about the Tech Artist Handbook, the progression of the book, the um, real-time visual effects for technical artists. You're going to have access to other things and goodies like the procedural gems goodies, which is coming out. I promise you. Be patient. It is coming out. And you're going to have access to all the other wonderful, wacky things that are tech art related. And you're going to have access through them through the TechArt EDU website. So go ahead, sign up, and check us out. Okay, that's all I wanted to cover today. Thank you so much for joining me, and I will see you again next week for Tech Art Talk Live. Arrivederci.